Welcome to Chapter 6, Chemical Equilibrium, the Chatelier's Principle. Now we shall proceed with the second factor, that is the effect of pressure by changing the volume. Changes in pressure or volume. Remember, it is only significant on the reaction that involve gaseous component only. If you have liquid, aqueous or solid, then any changes of the pressure will not be affecting the equilibrium constant or equilibrium position. Pressure changes if the volume of the reaction vessel is changed, the concentration or number of mole is changed, or a noble gas is added. Now, let's look at this. At constant temperature, reducing the volume of a gaseous equilibrium mixture causes the system to shift in the direction that reduces the number of moles of gas. Okay, so for example, the disturbance. Okay, so at constant temperature, volume reduce, pressure increase. Okay. Now, let's see what does it mean by the whole sentence here. Okay, for example now, okay, I have 4 gaseous molecules in this container. Okay, and then this is a 4 liter. Okay, then after that, I reduce the volume and becomes 2 liter. I still have the same 4 molecules. Okay, so what happened was, initially, for example, the pressure of the system is, okay, let's say it is 4. Means that the molecules hitting the wall, let's say 4 times. Now, when I reduce it to a smaller volume, okay, what happened is the molecule will hit the wall more frequently because the distance has been reduced. Okay, so now what happened is, maybe for example, it hit 8 times. Okay, so at equilibrium, it should only hit 4 times. But because I reduce the volume, and then it no longer in equilibrium because it has changed to 8 times. Okay, so what do I need to do in order to maintain the pressure that is 4 times only? Okay, so what I need to do is I can reduce the molecules. Okay, I can reduce the number of molecules. Then I will get back 4 times. Okay, so how to do this? Okay, then we need to look at the reversible reaction equation and make sure that we are counting the number of moles of gaseous molecules only. Okay, now let's see where will it shift to. Okay, on the right hand side, we have product only 1 mole. Okay, and then on the reactant, we have total 3 moles. Okay, our duty now is to reduce the molecules so that we can go back to equilibrium. Okay, so which side has less molecules? Of course, it is the 1 mole. 1 mole has less molecules, meaning that it will hit the wall less. So pressure will back to equilibrium. Okay, so what happened now is the equilibrium will shift to the right. Okay, it will shift to, according to the Chatelier's principle, equilibrium position shift to the right. Okay, thus more product will be formed. and reactant decrease. It doesn't mean that more product form and then the number of molecules becomes more. No, means more product is formed, but it's only 1 mole. And then reactant will decrease because reactant has 3 moles. So it will become less. Then equilibrium will be achieved. So remember, for changing the volume is very easy. If the volume, reducing the volume, pressure increase. Okay, so we use back the diagram. Okay, this is at equilibrium. Okay, so what happened is pressure increase. In order to go back to equilibrium, then we need to reduce the pressure. Okay, to reduce the pressure, we look for lower total number of mole of gas. We are not looking at left or right. We are looking at lowering the total number of mole of gas, okay, if pressure increase. Okay, now let's move on to other example. Okay, now when volume increase, pressure decrease. Okay, what does this mean? Okay, if we want to get back to equilibrium, what do we need to do? Okay, now pressure decrease. So in order to get back to equilibrium, we need to increase the pressure. Okay, increase pressure means more number of moles. Okay, so we look at reactant and product mole. Okay, reactant has more mole, thus the equilibrium position will shift to the left. Okay, and then less product will be formed and reactant increase. Okay, as a summary for pressure. Okay, if volume decrease, pressure increase, equilibrium position shift to the direction of fewer number of moles. Okay, I didn't say, okay, it's not to the left or to the right. It's pressure increase, shift to fewer number of moles. Pressure decrease, the equilibrium position shift to higher number of moles. Okay, now what happens if both reactant and product has the same number of moles? Okay, so there will be no effect on equilibrium position. Okay, now let's try one exercise. Okay, using Le Chatelier's principle, explain how increasing the volume. Increasing volume, the hint is increasing volume, pressure decrease would affect the equilibrium, and what will happen to the amount of ammonia. Okay, now we focus on equilibrium position first. Okay, so for pressure, if we are looking for pressure, make sure that we are calculating the number of mole of gases only. Okay, so this for reactant, we have 4 mole, 3 mole. So mole total equals to 3 plus 4 equals to 7. Okay, for product, 2 mole and 6 mole. So the mole total for product equals to 8 mole. Okay, so now where will the equilibrium shift to? Okay, so the disturbance is pressure decrease. Okay, again, draw the line at equilibrium. So pressure decrease going down. So in order to go back to equilibrium, we have to increase the pressure. Okay, if we want to increase the pressure, means the number of mole must increase or more. So which part has more number of mole? it is the product. Okay, so means that the equilibrium position will shift to the right, and then more product will be formed. Okay, now let's fill in the blank. Okay, so always start with according to Le Chatelier's principle. When the volume of system already given increase, pressure of the system decrease. Thus, the equilibrium position will shift to the right. Why shift to the right? Because we want to increase the pressure. If we increase the pressure means we want to increase the number of mole of gases. Okay, so what happened to ammonia? Ammonia is on the left hand side. Okay, but now it shift to the right. So means reactant will reduce or decrease. Okay, so now again, highlight, pressure is only for gases only, and then we look at the disturbance, either pressure increase or decrease, and then we go for, if pressure increase, fewer number of mole. If pressure decrease, higher number of moles. So always go back to this equilibrium, then see where is the direction. Okay, so that's all for the Chatelier principle, factor of changing the pressure of by changing the volume.